This video is on factoring trinomials. Trinomials are anything of the form x squared plus bx plus c or ax squared plus bx plus c. Of course, you could have positive or negative signs, but this is what we want to factor. And so let's take a look at the steps. And as we look at the examples, we will follow the steps. So the first thing you want to make sure is that you're going to look at your trinomial and check the order. The order should be largest exponent to smallest, so it should look something like one of these. The second step is if you see that your trinomial has a greatest common factor, you must factor that out. Third step, we normally write 2 parentheses in order to factor, and so that would be your third step. Write the 2 parentheses, and then we want to determine what the signs are inside the parentheses. And to determine the signs, we would use our sign rules. And so what you do is you look at this last term. Is that C term positive? If the C term is positive, then you have the same sign in the parentheses. If your C term is negative, if that last term, if it says minus, then you have opposite signs inside of the parentheses. And then once we figure out the signs, then we want to factor, and then of course you want to check your answer. Any of these problems are easy to check, so always check your answer at the end, and I'll show you how to do that. So we'll keep these steps in mind, but let's take a look at the examples. So we have our first set of examples. What we want to do is factor completely. And so here's the first example. We have a trinomial, 3 terms. The first thing you want to notice is that this is not in the correct form. It's not in the correct order, and so we have to rewrite the problem. So remember, the largest exponent should be first. So we want to rewrite this first. Y squared should go first, minus 10y plus 9. So that's now in the correct order. Next, we want to check to see if there's a greatest common factor. There is no greatest common factor, so we move on to step 3. We write 2 parentheses, and then we have to determine the signs in these parentheses. And so I look at the last term. It says positive 9, and so then if the last term is positive, then the signs are the same. So the signs in this case are both going to be negative. And so if this is positive and your middle term is negative, then both signs are negative. And then we basically want to look at y squared. How do you get y squared? We need to write y and y, because when you FOIL or multiply these together, we have to get back to y squared. And then we also need to look at factors of 9 that are going to give us negative 10. So the only factors of 9 that will work would be 9 and 1. And so this is our answer, but we want to check our work. To check your work, you can FOIL this out and you'll get back to the original trinomial. Or a faster way to do this is you could multiply your inner and outer terms and just make sure that you get negative 10y, which we do. So that is our final answer. Let's take a look at the second example. So this one, we already have the correct order. There is no GCF, so we just write 2 parentheses. And then we need to figure out the signs. And so the last term here is negative. And so I know that one should be positive, one should be negative. There should be opposite signs. I don't know which of these should come first. It doesn't really matter. You just need to make sure you put your factors for 32 in the correct place. So again, to get x squared, I need to have x times x, and then I need to look at factors of 32 that when we subtract, we get positive 4. So the only factors of 32 that would work would be 8 and 4. 8 should be positive, 4 should be negative, because when you check your work, you have to get back to positive 4. So really quick, to check your work, multiply your inner ones, that gives me 8x. Multiply the outer, that's negative 4x. When you combine these, we get positive 4x. It matches the middle term, so we know that it's correct. Also, you can FOIL and get back to the original trinomial. So factoring is actually the opposite of FOILing. Let's take a look at the third example. So this one, we have two variables. As long as the first and the last are squared and then the middle term should have a product of both variables, then this is in the correct order. So I don't have to worry about the order. The next step is to check to see if there's a GCF. In this case, there is. The GCF is 2. That needs to be factored out first. And so there'll be an extra step in this problem. Factor out 2. You need to write what's left after we factor that out. So I factored out the GCF, and at this point, I'm just going to focus on whatever's inside the parentheses. That is what we need to factor. I do not look at the top part of the problem. We only focus on the inside, and we do have to make sure we bring down our GCF. It is part of the next step and part of the answer. So at this point, we write 2 parentheses. To get x squared, you need to write x times x. The last term is negative, so we need to have opposite signs. And then I need factors of 15. So factors of 15, so that when you subtract, you get negative 2xy. In order to do that, we need to use 3 and 5. You need to figure out which should be negative, which should be positive. In this case, 5 needs to be negative, 3 needs to be positive, and since we have this extra y squared, I need to make this 5y and 3y. When you multiply these two, we need to get y squared. And also when you check your work, that's 3xy, and that's going to give us negative 5xy. When you combine these, we get negative 2xy, so it's correct. And this is our final answer. Let's take a look at the fourth example. So this is a little bit different, this problem. We're going to follow the same steps, but it's different because I have a coefficient in front of x squared, and it's not 1. And we can't factor out this 3. And so this coefficient stays where it is. And this example, 4, 5, 6, is going to be of this form, where we have a coefficient in front of x squared that's not 1. You'll follow the same steps, but we have to focus also on factors of a. And so the order is correct. There's no GCF. We write 2 parentheses. The signs should be opposite based on the sign rules. We need to look at factors of 2 and now also factors of 3. The only factors of 3 are just going to be 3 and 1. There are no other factors. And so we're going to have 3x and x. It matters where you put the terms because the signs are different in this case. And also, this is a 3 and that's a 1x. Factors of 2 are just 2 and 1. And so we need to figure out where to put our 2 and where to put our 1. Remember that when you check your answer, you have to get positive 1x. And so I need to place the factors of 2 in such a way that I get 1. So we need to put 1 here and 2 here. And so when you check, this is 3x, and that's going to be negative 2x, which when we subtract, we get positive 1x. Sometimes you might place the signs in the wrong place, or you might put the factors in the wrong place. Just use a pencil so that you can erase it and fix it. And so we have our final answer. The more you practice, the better you'll get at these problems. Let's take a look at number 5. And so the order for this one is correct. There is no GCF, and so I just directly skip to writing 2 parentheses. The signs will be opposite for this problem as well, and so I know they'll be opposite, so plus minus, and we have to look at factors of 15 and 15, the first and the last factors of both. Well, factors of 15 are 1 and 15 or 3 and 5, so we need to figure out which one we should use. I suggest we start with 3 and 5 and try that. So let's try 5m and 3m. And then I also need to look at factors of 15 for the last number, but I'm going to use 3 and 5 again. I'm going to put 3 here and 5 here. And so there's a trick for this part. The reason 3 goes here and 5 goes here, one of the reasons, is because if I put 5 in the first one, there'll be a GCF of 5. And then if I put 3 in the second one, there'll be a GCF of 3. So as a rule, if there's no GCF in the trinomial you're factoring, then there should be no GCF in any of these 2 parentheses. And so sometimes that will help us eliminate certain places that we could put the factors. So this would be our final answer. We just need to make sure that it's correct. So just quickly check your work. This is 9m. That is negative 25m. And of course, when you subtract, we get negative 16m. So I know that that's correct. Number 6, I see that the order is correct. There is a GCF, or actually, yeah, there is a GCF here. GCF is A, so we need to factor that out. Next, I bring down the GCF. We write 2 parentheses. Remember that we are only factoring whatever is inside the parentheses. That's what I need to focus on. And I need to look at factors of 3 and factors of 8. In this case, all the signs are positive, and so I know that the signs in these parentheses should also be positive. I'm going to start with 3. Factors of 3, I only have one choice, 3 and 1, so that's the only way to write it, 3 and 1. And then I need to figure out factors of 8. So factors of 8, there are a few. I'm going to write them on the side here. I can use 1 and 8, 2 and 4. So it's only going to be one of these. I can't use both. So we need to figure out which of these pairs will work so that we get 14. So remember, to get 14, inner product and outer product, we need to get 14a. And so if you think about it, the only way that that's going to work is if we use 2 and 4. And so we need to put 4a here and 2a here, because when we check, we're going to get 2a and then we get 12a, and if you combine those, we get positive 14. So you just have to think about where to put these numbers so that you get positive 14. Like I said, it's a little bit of trial and error at first, especially if you have never done this before. Let's take a look at the last two examples. So for this next example, we have two variables again. So we have x and y. As long as the first is x squared and the last one's y squared, and you have a product of both x, y in the middle, then this would be the correct order. So let's take a look at the problem. There's no GCF, and so then I just write 2 parentheses. And in this case, since the last term is positive, both signs should be the same. So both signs will be negative because the second term is negative. And then I need to look at factors of 25 and 36. So factors of 25, we can try 5x and 5x. And then factors of 36, 36 has many factors, but remember we have to get 60 when you multiply inner and outer. You need to get 60xy. And so the only way to get 60 is to use 6 and 6. And let's make it 6y for both, so we get y squared. So quick check, we get negative 30xy, negative 30xy, and that gives us negative 60xy. Now for this problem, since these two are exactly the same, these two factors, you can also write your answer as 5x minus 6y quantity squared. That is also correct. So we could write it this way, or you can write the two separate factors. They have to be exactly the same with the signs in order for us to write it this way. Last example is in the correct order. There's no GCF in this case, and so again, just 2 parentheses, and I need to look at factors of 18, and I also need to look at factors of 14. So for 18, factors are 1 and 18, 2 and 9, 3 and 6, and then for 14, 1 and 14, 2 and 7. So I'm going to start by using 2 and 7 to see if that works. And then also for 18, we need to figure out which one would work. Let's go back to the problem. Last number is negative, so the signs should be opposite. I said I'm going to try 2 and 7. So I'm just randomly going to put 2 here and 7 here. If we have to switch the signs, we could do it later. And then I need to figure out how we're going to get negative 9x. So let's look. I'm going to start with 3. Let's try 3 and 6 and see if that works. So what I'm going to do is put 3 in the first parentheses. I cannot put 6 in the first parentheses because there'll be a GCF. And so if we want to test 3 and 6, 3 has to go here, 6 has to go here. There's no other way to do it because then there'll be a GCF. So let's see if that works. 3x and 6x. So you multiply, this is 12x, multiply those, we're going to get 21x, and then, or negative 21x, and then we have to subtract. So when we subtract, that comes out to be negative 9x, and so I know it's correct. And that is our last example.